Welcome back to an extra special edition of the Tech Will Save Us podcast. It's extra special, not least because we've got some fantastic guests, but we're also live. So I'm going to remind our guests, but mainly myself, not to swear or say anything incriminating. This week, we're talking about manufacturing and 5G. We're joined by Karl Connolly of NetMaven and Martin Alcock from Razer. So guys, do you want to start just by sort of giving a bit of an introduction and a bit of background on yourself, starting with you, Karl?
Hey, thanks, Callum, and thanks for everyone for joining. My name is Karl Connolly. I'm a chief technologist and one of the co-founders of NetMaven. I started my career in technology in the year 2000 at a company called EMC in Hopkinton, Mass, where I live. I did a lot of things there over the course of 17 years. I was a hardware software engineer, worked in corporate systems engineering, worked in integrations, kind of got bored with technology for a bit and went into the legal side of things. Was in private practice for 3 years, came back to global distribution, was chief technologist. And over the course of 5 years at Ingram Micro, I really got involved in 5G. And my business partner and I founded NetMaven this year. We are 5G consultants helping partners and customers embrace 5G. So really looking forward to today's call, and thanks for having me.
Great, really nice to have you here, Karl. And then over to you, Martin. Do you want to give a brief introduction, a bit about your background?
Yeah, sure. My name is Martin Alcock. I am principal product consultant at Razer. I have been in industry since about 2008 in various different forms. My role here at Razer is really about talking to our clients and understanding their requirements, and then translating those requirements into something that we can build with technology and then actually go and solve those problems. Yeah, I spend a lot of time talking to manufacturers, all sorts of different people in different verticals and different industries. And yeah, I find it very interesting to find out about other people's problems and then come up with solutions and how we can solve those problems with technology.
Great, great to have you both here. I think we're joined by a third guest as well, Dot the dog. You might not be able to see her, but if she barks, it's a quality control bark, I'm afraid, instilled by Martin. Bringing it back to the topic of the conversation then, Karl, can you start sort of give us a bit of an overview of what 5G is and how it might differ to sort of traditional networks and Wi-Fi systems?
Yeah, sure. It's a big topic, but I'll try to make it relatively simple. 5G, first and foremost, as the name implies, is the 5th generation of cellular technology. It's unlike all the other Gs, though, in the sense that this model, 5G, is well and truly a software-defined architecture. So in the past, if you wanted to build a 5G network, you would go to one of the major providers and you get proprietary equipment, hardware, software. Now that's kind of unlocked. There's a governing body that dictates what goes into 3G. So this means that the current release very much looks like a software application, which is great for consumers and enterprises because they can take advantage of upgrades over the course of time. 5G is very different from 4G, 3G, 2G, 1G in the sense that it's actually made up of 3 distinct bands of spectrum, which we can talk about a bit later. But that consists of low band, mid band, and high band. Each of those have different attributes, which bring different characteristics to the network. But when combined together, it's just incredibly powerful. So you asked about the differences between 5G and traditional networks. I think traditional networks, we think about Ethernet, which is wired typically connection. It's really hard to beat wired connectivity for reliability and speed. However, there is a downside with wired connectivity, specifically in factories and manufacturing. That is to say, you've got this umbilical right from the device to a switch, and therefore you obviously have to run a cable. Running cables can be very expensive, costly, time-consuming, and to be honest with you, fraught with issues. I'm sure many of you have heard of enterprises where the cable's been accidentally cut, and in that instance, the business is down or perhaps isolated from the network for a period. Moreover, I think if you think about a modern factory, and we're certainly going to talk about that, they're very loud environments. They're very kind of dynamic environments. And anytime you've got cables on the ground, well, it's a potential risk for someone to fall or slip or trip. So the alternative to wired is obviously Wi-Fi, and many factories and environments actually have Wi-Fi, and Wi-Fi is perfectly fine in many applications. However, what we're seeing now, Callum, is that networks are getting saturated. There's more and more devices on a Wi-Fi network, and therefore, in order to support that, you'll have to build extensive networks. When I think about 5G in a factory environment specifically, it's really the ideal protocol for connecting a lot of devices. So if you think about the speed, first and foremost, which is very important in modern environments, you can get near wired speed over the air, which is much faster than Wi-Fi. That's number one. I think second, the big factor is latency. Latency obviously is the time that it takes to send a signal and get something back. Now, Wi-Fi is pretty good, but in a modern factory where you're looking at machines that have machine-to-machine communication, which is now really the norm, you need ultra-reliable, low-latency communication for machine-to-machine communication, sub-5 millisecond latency, and that's only possible over 5G. I would say to Callum, capacity. The standard for 5G is that it must support 1 million devices in a square kilometer. Now, needless to say, your factory probably hasn't got 1 million devices in it. But if you're thinking about building a factory or thinking about network modernization, why wouldn't you want to build a future-proof network, right? So you build a 5G network, it can absorb those devices and be that kind of network as you grow. And I'd say last but not least, just to round it out, from my perspective, when we're thinking about modernization, factories, automation, real-time processing, what's the common denominator that I really need? It's reliability. And the reliability of 5G networks has been proven over Wi-Fi. It's a much better protocol in the sense that they don't break it till they make it. That is to say that if you're a automated guided vehicle or whatever, you don't break the signal until it's actually being passed over. And that's not true for Wi-Fi. You might find an AGV that's kind of orphaned off on a Wi-Fi network. So when it comes to 5G, there's those benefits, but also intrinsically security is a big factor too. And the standard for 5G is leaps and bounds more advanced, I would argue, than Wi-Fi.
Excellent. Yeah, you really sort of illuminated 5G in an industrial setting there. I wonder, Martin, if we could sort of look at some of the challenges within modern manufacturing and go through some of them, and then we can start to think about what benefits to the modern manufacturer and what sort of improvements they might see with the adoption of 5G.
Yeah, sure. I mean, yeah, in my role as a consultant at Razer, I've been meeting a lot of, we sort of broke into the manufacturing space a few years ago, and we kept on seeing the same kind of things occur over and over again. Very often it's about trying to understand what's actually going on the factory floor, right? They know the machines are producing something. They know that they are they're putting widgets out the front door, so to speak, but they don't necessarily know, are they at capacity? Are they getting the most out of their assets as they possibly can do? Can they squeeze some more out of, can they make sure that their downtime is planned rather than acute and something that has to stop production? And all of this kind of stuff all comes down to, can we get the data and can we do something about that data? And once you've got that data and you can start generating insights out of it, that's where you can start to move the needle. And this is what we're talking about a lot of the time with Industry 4.0. It's not necessarily a brand new manufacturing technique. It's understanding your existing manufacturing techniques better. And obviously at the core of all this, there's like connectivity. And as Karl said, like it's a case of, do you run wires across your factory floor, which in some factories, it could be hundreds of kilometers worth of wiring just to get that data, and that's prohibitively expensive or time consuming to go and get it. And like sometimes it's going to be very difficult to even get a cable into the right spot. So when we're talking about like connectivity technologies like Wi-Fi or 5G in this case, it really does open out possibilities of how you can go about getting this data and then doing something useful out the other side of it.
Yeah, I'll just dovetail, if I may, Callum, onto what Martin just said. I think that's very important. You mentioned Industry 4.0. 5G and edge computing, they're kind of a marriage made in heaven. That is to say, you put the services of the network out to where the action is. And as Martin said, while there are many factories that are still kind of antiquated, many of the production line managers are looking for ways to kind of modernize those factories without disrupting the machines themselves. So I've seen some innovative things where you've got some legacy dials or some analog systems, and you can add to them sensors, IoT sensors, or similarly cameras, smart cameras that are actually, have machine learning and AI running on them, such that they can take an image of that gauge that's moving up and down, and then make some inferences on that, and actually now leverage those movements to make a determination on the state of the machine. And as Martin said, every single minute in production that is out is dollars, pounds, euros lost, right? So the mission is to avoid that at all costs. Back when I was at EMC, we launched a platform, a hyperconverged box, where we actually had the boxes dial home. And we would then know, for example, when a component in those devices would fail based on what the OEM was telling us. And then we were kind of crowdsourcing from all the boxes deployed. So we could actually send a disk out before the disk would actually fail. You'd look at the average time that disk would fail, then you send the disk to the customer, they'd be delighted, right? Because you could avoid that potential outage. If you think of that in grand scale in a factory, though, that's only possible now with being able to take, as Martin said, the data off of those machines and make sense of that data, and then translate that into something that is beneficial to the business, aka predictive maintenance, such that you're avoiding the scheduled outage.
Yeah, absolutely. And I suppose having it sort of outcome focused is one of the things that we try and do at Razor. It's all good having all this data, but actually data without insight is just an overhead, as we know. So starting with the end in mind and using that data in a practical way. So I'm wondering, with that in mind, around sort of improving operational efficiencies and going down that sort of avenue, as it were, what can 5G do specifically to sort of help on that improvement of operational flow?
Yeah, so I'll give you an example. Last year, I was involved in a project at a place for anybody in the States called MXD. MXD is an organization in Chicago that brings together different manufacturers in a community with the sole purpose of developing innovation, helping American companies thrive. It's a great kind of environment to learn, to see, to engage with people in your peer group and see what challenges they have. So we built a sort of a factory of the future in the showcase there, where we had, if you can imagine, a legacy conveyor belt with a bunch of products going around it. Now, in a real world environment, those products are moving incredibly quickly. So it's very hard really to, pick and choose which ones are good. But if you can employ a camera or a set of cameras with sensors and AI and computer vision that can actually interrogate and inspect those products as they're moving through the conveyor belt at speed, you can really identify anomalies in the production line or take, faulty products out very quickly and easily. And needless to say, as Martin just alluded to, those cameras are actually edge compute, right? So they're producing a huge amount of data, and that data has to get crunched, it has to be normalized, and it has to be translated into something meaningful. So with 5G and edge compute, you can essentially create a lot of data, but transfer loads of data and normalize that data, make sense of that data in real time. That's the important aspect of it. And that's not possible over Wi-Fi. It doesn't have the latency to keep up. I think Martin also mentioned factories being flexible. That's very important. In today's environment, in order to stay competitive, a factory must respond to consumer demand. And if you think about a factory, just the sheer size of it, legacy factories are very kind of static. Modern factories, though, are very dynamic. And if you have to uproot your network every time you want to introduce a new product, that's a nightmare, right? It's going to be costly, it's going to be time consuming, and it's going to ultimately reduce in production outage. So with a 5G network, it's essentially, that wired speed over the air. You can reconfigure and calibrate your factory relatively quickly. And we see this all the time in auto manufacturers and airline manufacturers, Airbus, Boeing, classic examples. I would also say that the amount of data coming off, and you guys are experts in this, off of those machines now helps organizations drive innovation, right? Because you're now touching into what was untapped data before and potentially developing new solutions or new optimizations or new cost-cutting schemes, or in fact, deriving new products from the data itself.
Yeah. I think I want to touch on one of the things you said on there about like the latency and actually using camera data and stuff. I think people have a bit of a misconception about what 5G is because you have it. I've got a 5G phone, and really it just means that I can download videos a bit faster. Like 5G, when we're talking about it in industry and in factories, it's quite a different beast, isn't it? Like, can you give us some impression of like how much data we're talking about when we're transferring here?
Yeah. Well, it's really going to depend. Most of us as consumers, when you see the 5G show up on your phone, you're like, okay, that's great. My YouTube video may come down faster than it was before, or there's less jitter. But when you get into very large environments, like hospital environments, for example, that have epic systems where you've got massive amounts of data from DICOM images, medical images, that a clinician needs to access on the go. If you try to do that on Wi-Fi, unless you've got the place blanketed in access points, which are needless to say expensive, it's very challenging, and that goes to the whole continuity of service. So you're right, Martin. In the industrial setting, what's typical is the providers are giving you a service with different bands of spectrum. So depending on the use case, IoT, for example, probably doesn't generate a ton of data, and therefore low band is perfectly fine. In the enterprise, though, what we call the innovation band, or the Goldilocks band, is the C band, and that's between 2 and 7 gigahertz. That's the sweet spot for enterprises in terms of consuming 5G, because it's the right set of 5G spectrum that gives you capacity, coverage, and capability. And then for the ultra high, low latency use cases, sub 5 millisecond, you're going to want to subscribe to millimeter wave. And so from an enterprise perspective, when you're engaging with a mobile network operator, they're going to typically come in and assess your entire production workload, and then build a custom network that typically consists of all of those spectrums combined under the 5G umbrella. That's the nice thing about 5G. Although you've got different and disparate spectrum, which is essentially the airwaves, you're using what's called a 5G core, which is the software-defined services, which enables you to do some really innovative things. One of those things is network slicing. And that's essentially where, to your point, Martin, if you're an enterprise and you want to dictate your exact requirements for your network for a specific application group or users, you can do that now with 5G because it's software defined. You can basically go, I want this bandwidth, I want this reliability, I want this security protocol, and I need this bandwidth or this spectrum, and you can get a carved slice of virtual network, so to speak. So that's the future, and that's why standalone networks are really important.
Yeah, I think you just touched on security there. It's just a growing concern, like particularly like the current geopolitical climate's going on. Like we at Razer have talked to lots of manufacturers where they are talking about security in terms of like national security sometimes.
Yeah.
They have air-gapped systems. The operational technology never touches the outside world at all. So when they're talking about like, can we get some wireless capability so we can see insights and dashboards on an iPad or something, it can become a real big headache for them to actually start getting this data out.
Yeah.
So yeah, like the sort of the security that's just baked into the actual whole connectivity layer within 5G is really important, and it's I think something that people are perhaps missing a lot of the time. It actually solves a lot of these security problems right out of the box, doesn't it?
It does. It does. If not to get super geeky here, but
this is a place for it.
so as I mentioned at the onset, the governing body, the 3GPP, has basically defined what goes into 5G, what the release cycle should be, and what the attributes of the standard should be. And needless to say, when they were thinking about the next wave of fifth generation of cellular, cybersecurity is everywhere and in the news, and it's on the front of everybody's mind. And there's been horrific ransomware and hostage situations from a data perspective that we all have read about. And so intrinsically, 5G is much more secure than any of the previous versions of standards, which is good to see. Authentication, encryption, and the fact, as you mentioned now, that security and network concepts are somewhat merged. 5G is a software-defined standard, so you can take advantage of ring fencing and micro-segmentation. and network slicing, as I said. So there are many attributes of 5G security that you can essentially bake in. And when you think about Wi-Fi, which is the alternative to 5G from a wireless perspective, the security is really at the SSID layer, but with 5G, it's literally at the SIM. So you've got that zero trust capability. And I work very closely with T-Mobile here in the US, and T-Mobile has a standalone network, which means that their 5G network is architected with no reliance on legacy 4G, which are the case with the other carriers in the non-standalone network. That means they're able to actually build software services into their core. And so they've partnered with a third party, Versa, to essentially offer SASE, Secure Access Services Edge, right into the network itself. So that combined with a clientless version of SASE running on the SIM really gives you that kind of granular control. And that's really important, especially in industrial controls, because if you don't have to install a software client, many of those legacy IoT devices, which are the Achilles heels in factories from a security perspective, don't have sophisticated operating systems. And therefore, the average antivirus or protection scheme won't get installed. But if you are basically embedding the security service in the SIM or eSIM as a software service, well, you're solving that problem. And that's a huge issue. Because we've read about issues where a hacker comes in through an AC unit, which has a very rudimentary control, but they get in and they sit on the network then and extract data for months, stealing secrets, as you said, or potentially holding that business up for ransom, or decommissioning IT systems, even worse.
Yeah, I remember talking to some penetration consultants a few years ago, and they were telling me about a company that got hacked because someone had installed an IoT thermometer in a fish tank, and they managed to get onto the network through that. So
yeah, good for the fish, bad for the environment.
Right. Martin, when we talk about 5G, often mentioned in the same breath or a secondary breath is digital twins. Can you sort of just touch on what digital twin is and what it means in manufacturing?
Yeah, sure. I first heard about digital twins some number of years ago, and to be honest, when I first heard about it, I didn't quite get it. I was like, well, you can just sort of look at it and go, well, it's not working. But yeah, the scales have sort of been lifted from my eyes since. And yeah, I mean, we're really talking about, like, as the name implies, it's a digital twin of what's going on. It is a one-for-one representation of what's going on the factory floor in real time, based on reality. And once you're getting all that data, like on a first look of it, you can actually see what's coming through your factory, what's actually, what the machines are doing, how fast they're going, what sort of process, what things are coming out the other side of it. And obviously, once you've got all of that data, then you can start to do stuff with that data, as we touched on already. Like, you can start doing predictive maintenance, you can start doing predictive output projections, stuff like that. And you can really start to build out you can almost like simulate your entire factory. Once you've got all the data and you've got all the sort of access points and you've got all the sensors coming off all of the various different machines, you can basically simulate your entire factory. So you can say, like we were talking about before, the flexibility of a modern factory, you can say, well, okay, what happens if I get an order come through that is 5 times the size of what I would normally do? What's that going to do to the rest of my factory? What do I need to, like, buy more assets now? And when would I be able to, like, get the payment back on all of those kind of things? It really does, unlock a lot of the sort of the big picture, sort of exciting things we talk about when we're talking about Industry 4.0. It's one of the things that we've focused on with one of our internal products at Razor. As I mentioned at the top of the call, we've been working with manufacturers for a number of years. We talked to a bunch of them, and you start hearing the same problems over and over again, which is why we started creating our product MIP. And really, it was just to try and, like, get a handle on the fact that we've got all these people coming to us the same problem, and right, we can't just keep solving it over and over again. We just need to solve it once, and that's what we've done. And yeah, all of the sort of work we've done around that is really trying to get data off machines, no matter how old they are, who made them, when they came from, that kind of thing. Get all of that into a central point normalize it, and then once you've got that normalized data and you understand it, then you can start doing interesting, exciting things, be that sort of next generation visualization or machine learning processes on top of it, bringing in like really like sort of old things. We talked to manufacturers that have got equipment that's like literally 100 years old, and obviously they don't have like a PLC on them to get the data off by themselves. You have to start attaching literal cameras or edge device nodes, sensors and stuff like that. But you still need to be able to interpret all of that data into the same way. And then, you know, you get all these bits of sensor data, telemetry from stuff from 100 years old to brand new, and then try and normalize it in some way that you can then start to do these really exciting things. The stuff that people get really excited about when you talk about Industry 4.0 of, I'll be able to predict the future. That's what all of it kind of leads up to. And that's the sort of thing we've been working on.
We've been working on predicting the future.
Yeah, ideally, yeah. We'll
be up with lottery numbers by any chance?
If only we work with the company that builds the lottery machines, maybe that would be possible.
Great. I'll see you from where I land on the next one. I just can I Colin? So Martin raises a really interesting point. You know, aside from the optimization of the factory, we're starting to see digital twins now bleed into other areas. I'm working, in fact, with an amazing company that has a digital twin platform, and they're looking at working with the bottlers for Coca-Cola, believe it or not, in Florida. And part of that is to help the sales teams with share of shelf. So when these products go out onto the shelf, are they getting the right placement? And, you know, then you can figure out whether or not, you know, it's an economical venture in this store, or whether or not inventory is up to snuff, or whether or not they were placed correctly, and, you know, to the whole compliance. But last week I was actually down with the University of Miami, and they're now using digital twin technology in healthcare, which is really, really interesting. When you think about actual digital twin of a person, where they can assess, you know, procedures or drugs based on the makeup of the individual. So the technology is really growing, and I think really the sky's the limit. It's a very exciting area of technology for sure.
Definitely. I mean, when we talk about digital twins, it can be, from the sort of human scale of, it's really exciting idea of being able to have a digital twin of a person almost, right the way down to sort of micro scale of tiny little processes. And we're doing process monitoring, and we can get sort of millisecond or less resolution of a particular process that's happening, and then use that as certification data to say, like, this piece has been machined to within tolerance. And it goes all the way up to the sort of giant macro scale where you talk about smart cities, and you've got like a digital twin of an entire city going on. It's a huge and really interesting area of technology.
Yeah, just you just jarred my memory. So at that Factory of the Future, I worked with two companies to kind of do AR and VR, which is sort of an extension of digital twin, but on a micro scale. So RealWear create an augmented virtual reality kind of headset, and really cool technology. But if you think about the challenges in manufacturing, Callum, today, in the US, there's a big challenge, and I think it's the same in all developed the Western world, is there's a lot of retirement happening. In the US, 10,000 baby boomers become eligible for retirement every day. So 10,000 people a day. That's a huge brain drain from the factory. And so if you think about the ability now to use digital twinning or that kind of technology, where you can use smart hands to basically have maybe a core set of experts guiding then relatively younger employees, but using 3D models of a production line or a component, let's say, and then use augmented virtual reality, where the nearing retirement individual with all the knowledge is sort of central in command and control, but imparting that knowledge through a digital twin, through AR and VR, where you can essentially look at a shaft or something like that and actually peer into it, and then render that model such that you can pull up a schematic or a design on the fly in a spatial computing environment, it's amazing, right? So using the technology like that, I think, is really going to solve for that exodus out of the workforce.
Yeah. I love the Tony Stark imagery that you're painting right now.
Right.
I also really love. I know we're talking about manufacturing today, but the applications to other industries such as healthcare, like I mentioned, are massive. I know we talked about predictive maintenance of machines, but how about predictive and preventative maintenance of humans and diagnostic tools and all the rest of it that comes out?
It will be a reality. I mean, the fact is, most healthcare systems now are employing data scientists to do just what you said, right? So if you think about anytime we go to the doctor or have some interaction with the healthcare system, there's a record created. And that record typically sits in an electronic file today in some system, but it's very siloed and disparate. And so the real benefit, arguably, of using AI and machine learning is to look at these records and correlate them with each other, because heretofore that just doesn't happen. And if a human were to do it, it would take years and they probably miss things. So you could see that this individual had this condition at, say, age 7, and then was on this medication, or things manifested when they were a teen. And putting that together using, algorithms or an AI and machine learning model, it can now make a recommendation such that that person may get, a preventative care. Prevention's better than cure, right? So I think that's the future, and that's a great application, and we're starting to see that happen now.
Absolutely, it's very exciting. Just bringing it back ever so slightly towards the manufacturing, the industrial, and the dusty settings of these big. Just want to talk briefly about what implications 5G adoption could have on manufacturers with multiple sites. Does it make a difference if they've got one site or two sites or three, or they're a global site? And what sort of improvements might they see if they do adopt 5G across the globe?
Yeah, that's a great question. What comes to mind when I hear that is sort of like utilities or oil and gas, right? Those are environments where they have, let's say, maybe not manufacturing, they're manufacturing oil or gas out of the ground, but they're inhospitable locations, and they're probably hard to get to. Arguably, you can do a lot now with remote control, or send an AGV, a robot or a cobot out into those locations from a central location. So if you have a central location, you have multiple disparate locations, you can now connect those over 5G with a powerful signal that has enough bandwidth and low latency such that it's real time. And that arguably could translate into a more secure, safe, more efficient working environment if there's no human having to go there, right? Take the human out of the equation, typically it helps. I would say too, as was apparent with COVID, we all suffered from supply chain, right? That was a huge problem. And that translated into all kinds of downstream issues for the economy. If you have a 5G network that's able to monitor the transaction and the production of good, or even introduce things like blockchain for compliance reasons, a 5G network is really perfect for that, because it's essentially ubiquitous and gives you that kind of global collaboration and coverage that you need. Because most manufacturers today are playing in the global economy, and therefore, even though their factory may be localized, when they have to think about the market that they serve, it's truly global. And therefore, having network capabilities that gives you the ability to traverse borders is very important. And obviously 5G is really well suited for that kind of mobility challenge. And with the new standard, that the next version of 5G, which is software defined, remember, so it's just going to be an update, a release, is non-terrestrial networks. So essentially using satellite connectivity to beam down 5G signals, which definitely solves for issues when you're not on land. So if you've got shipping containers, right, that need to have constant collaboration and communication, very difficult. But now that's solved because you're essentially tapping into a satellite and then hitting the terrestrial for downstream. So 5G really, from an architectural perspective and a capacity and coverage perspective, is an ideal platform for innovation to solve these kind of multi-jurisdictional factories.
Yeah, it's interesting. And I wonder, we've talked briefly there about taking the human out of the equation. We're talking about automation now then, and how important is automation in manufacturing, and how can 5G sort of help to speed things up and improve things?
Yeah. So as I mentioned, the big issue right now that a lot of manufacturers are trying to solve for is that exodus from the workforce. So how do you solve that human challenge? Really, it's through automation and potentially robots. So AGVs, automatic guided vehicles, are now getting more pervasive. Robots now, which were science fiction before, are pretty commonplace actually. And one of the attributes of the 5G standard is machine-to-machine communication. So when that governing body dictates what goes into the releases, there's three buckets or three use cases that they focus on. One is ultra-reliable, low-latency communication. Second is machine-to-machine communication. The other is fixed wireless access. So the standard is built for machine-to-machine communication. So that really helps with robotic controls, because robots, as you know, can't tolerate latency. And so with 5G connection, you have that bandwidth and you have that low latency such that it's automatically responding. Like a human has about 240 millisecond latency. Pretty slow. A robot can tolerate sub 5 millisecond latency, right? So that production line speed, it's not possible with Wi-Fi, and so 5G really helps with that. I think too, the combination of human and robot collaboration is not too far away. As we talked about, sending machines into inhospitable places or having remote control control of those devices is a thing now. And then, of course, automation, 5G supports, as we talked about, the extraction of a lot of data. That data translates into creation of more streamlined, more efficient processes. So really, at the core of it, when you boil down what's the common denominator in all of these things, it's really a ubiquitous, low latency, high speed, high bandwidth, reliable communication platform. And whether that's a combination of wired 5G or Wi-Fi, well, so be it. But 5G ultimately is an amazing protocol for all of this.
Yeah, I think it really does unlock a bunch of use cases that just weren't really practical without it before. Like you said, like things out at sea, you've got multi-jurisdictional kind of things. If you can avoid, obviously, like if you're out at sea, cables aren't really going to work for you. But then your alternative is satellite uplink, but then there's quite a bit of latency involved with that, and it really does sort of sidestep a lot of these problems, doesn't it?
Mm-hmm. And we talked about it briefly, but with the different bands of 5G spectrum that is available, or it's part of that 5G service, the low band is perfect for that. The low band basically is like, those old radios that had long wave, right? It goes great distance. Now the speed may not be as good as the other bands, but it's still taking advantage of the software defined, so it can still employ network slicing and things of that nature. But for those long distances, low band is perfect.
Yeah, sure. I think one of the things you touched on before about the sort of retiring workforce, I had no idea. It's 10,000 a day for retiring in the US. That is
eligible to retire.
Of course,
whether they do or not is questionable, but it's a huge problem.
Yeah, I mean, it's something we're seeing a lot of as well. Like Razer is based in Sheffield. It's one of the oldest manufacturing hubs in the world, really. That's not to say all of the staff at Sheffield manufacturers are as old as Sheffield has been manufacturing for a long shot.
You wouldn't be far off in that assumption, though, would you?
Maybe not. But you see, like, we meet a lot of people where they introduce us to, here's Dave, and he's been here for 50 years. He's been here since he's a boy. And the process is we build the thing, and then Dave looks at it and he goes, yeah, that seems right. And that's he's got so much skill and knowledge built up over decades of experience that you can just look at it and go, yeah, that looks good. But how do you translate that into someone coming up from apprenticeship and being able to just have that level of skill and knowledge and stuff? And it really does come down to being able to capture all this data, being able to do it reliably, being able to process it in a sensible way that then you're able to actually turn it into something useful on the other side. I think we find a lot when we talk to manufacturers, like if they've been bitten by the 4G industry 4.0 bug, they go, yeah, let's get some data. And we go, why? What are you trying to achieve with it? Yeah, let's get some data, but then what happens? Um, and it's a really interesting time where we've got a big cohort in the baby boomers that are all sort of starting to retire and looking at it if they're not already retired, and taking loads of skills and knowledge with them that are very difficult to pass down because it's it's something that are born out of decades of experience, right? And then the way we can do this and the way we are able to stay competitive in the global market is really to capture this data, which is, for a lot of manufacturers, that's like their secret sauce. It's industry secrets. It's stuff that they can't have ever leave the factory site because that's what keeps them competitive and gives them their USP. So you've got this like security requirement, you've got this need to capture really staggering amounts of data that no one's ever really tried or needed to do before. And then, obviously the storage and processing of all of that stuff. And really, when we're talking about factory of the future, having this flexibility built into it, being able to maintain security and operational security of that factory site to maintain their competitive nature, you really do need to have like a flexible solution like 5G and be able to reconfigure your site as you need to respond to changing market conditions. It's really timely technology. Let's say it's really turned up at the right time.
Yeah, but talking about things turning up at the right time, have to shout out to Razer. I mean, I think your approach is amazing, and we hear now every single tech conversation is AI and machine learning. And people don't start with what you just described. And that's the problem of Dave, right? So what happens when Dave retires? Well, will someone be able to pick up? So to have a Razer or entity like Razer actually come in and look at the processes, understand the clinical hospitals on the brain, the workflow. The workflow is very, very important. What does Dave do every day? Or what does Dave look at? What's that tribal knowledge? Where does that data sit? Not all data, most data is not in a database, it's unstructured, right? So the ability to come in and do a complete data assessment and a process assessment, and then to distill that down and build a customized application, leveraging the data. And as we talked about, maybe extracting new value from that data that heretofore just wasn't exposed is quite amazing. So I think there's, for anybody listening, I shout out Razer all the time because a lot of people are talking about it, but who's actually doing it? And you guys are actually doing it, but doing it in a way that actually makes business sense. That's the same way we approach 5G, to be honest with you. The last thing I talk about is 5G in the network when I have a conversation with the customer, because that's a surefire way to have them roll their eyes back and go, oh God, kill me now, right? It's like, what are you trying to solve? Yeah. What services would you like to offer that your network is impeding you from doing? What are your employees moaning about? Relatively speaking. We try to come in and look at things from a business perspective, then a financial perspective, and then a technical perspective, because the last thing you want is a forced fit. So I get this question all the time, is a Wi-Fi, is a 5G? And I'm like, listen, it's both, right? Yeah. At the end of the day, it's trying to figure out what's the right solution for the customer. Their IT staff probably knows Wi-Fi, so they're pretty comfortable with that. But Wi-Fi has limits, as we've just talked about. And so bringing something new into the equation typically is a little bit of, oh crap, oh no, we can't do that. But that's why it's really good to partner with partners that can bring in things as a managed service and then offer it sort of holistically, or figure out, we're not going to get into this war of, Wi-Fi versus 5G. Let's look at this together and figure out which applications and workloads potentially could go 5G and which should stay on Wi-Fi. Because what we've actually seen, guys, is that when we offload the burden off of the Wi-Fi network and put that mission critical workloads and applications on the 5G network, well, guess what? Your Wi-Fi network suddenly gets a shot in the arm because it's no longer struggling with the mission critical data. And therefore, low-level processes that are perfectly suitable for Wi-Fi are on Wi-Fi. And that's a much better return on the investment when you look at the total cost of ownership for the customer.
Yeah. Well, thanks for the shout out, Karl. We'll cut that bit up for sure, and we're plastering that around. But you're absolutely right. Yeah, exactly right. Yeah, we didn't pay him to say that, honestly. You're absolutely right. It's technology second, and speak to the Daves of this world first. I know we're talking about a technology today, but we're really talking about solutions and solving problems. Just to tell something you said there about adopting certain technologies like this. Like, what are the sort of common misconceptions around 5G that customers still have, and what are the blockers that are preventing people from adopting this right away?
Yeah, I'm going to say the biggest blocker is, and this is going to sound like a horrible use of the term, but ignorance. And that's because before 5G, 4G was really the domain of the carriers, the mobile network operators. And people who adopted 4G perhaps had a anticlimactic experience because it just wasn't really built for the enterprise, relatively speaking. 5G is very different, as we've just discussed. It really is at its core designed for enterprise, and an enabler of enterprise. So the first hurdle, really, to be honest with you guys, is to help IT understand that cellular is not the devil, that it is a viable alternative, and that they don't have to necessarily manage it. Therefore, we would bring in, T-Mobile. They have an ANS group, which is Advanced Network Solutions Group here in the US, that goes in and helps that IT organization assess their needs and then delivers that as a managed service. On the flip side, I also have another partner, a great partner called Betacom, and Betacom offer CBRS as a service, which in the US is unlicensed 5G spectrum, again as a managed service. So what we try to do is help the IT team realize that bringing this capability into their environment as a managed service, where they don't have to worry about the management or the securing of this additional network capability, is only going to help the enterprise achieve its goals. I think that's number one. Kind of coupled with that, arguably, is the skill set gap. And that's the natural fear factor. IT people, they're really always feel kind of ashamed if they don't know something. Like, well, how can you know everything, right? The technology is evolving so fast. The smart IT people are the people that partner with partners, in my opinion. And so we have to kind of get over that. And then arguably, to be perfectly honest, there's an economic discussion that needs to happen. A lot of people will automatically think, oh, I'm bringing in a cellular network, that's going to cost me an arm and a leg. Okay, it's not inexpensive. But if you look at the total cost of ownership over time, cellular becomes very economical simply because of the device density that you can employ. We talked a little bit about this, but as organizations are looking to upgrade Wi-Fi, 6E needs 2 cables for every access point. Wi-Fi 7 needs 4 cables for every access point. And so if you think about that, right, there's only so many devices that those access points can support on Wi-Fi. And so in a large factory environment, or a very large airport, let's say, for example, you're going to need hundreds of access points, running access points, running cables, price for hardware, price for software, price for managing, price for monitoring, price for humans. It gets very expensive. On the flip side, while cellular, you obviously have to run some cables. You use less access points, right? So you have much greater device density. And therefore, from a total economic perspective, and as we talked about, if you're building a network for future growth, why not build it once and have all of that bandwidth and luxury built in, versus having to piecemeal it together with the Wi-Fi? So I think when we talk about it, we talk about it from a skill set gap, the fact that you can acquire a managed service, but also economics. Those are the big barriers, I would say. And just pure never having an opportunity to participate in this space, because prior to 5G, it was very much a lockbox system, right? It was Huawei, Ericsson, and Nokia. You buy the gear from there. Now you can buy cores that are running in the cloud, or services that are running on commodity off-the-shelf hardware. So the whole environment for 5G is much more open. So I think slowly but surely those barriers will erode, and as we get into 6G in 2030, it'll be a much smoother transition, and I think those legacy concepts of the office of no will dissipate.
Great, yeah. Bit of a leading question, but I suppose, given that it's a fairly new technology, what are the potential risks? I suppose the question is, would you rather be the first person with the new technology or the last person on the old technology, really?
Yeah, so that's a good question, Callum. To be honest with you, 5G has been around, or at least publicly available in the US, where I am, since 2018. So it's 2024 now. That's 6 years, and there's been scores of deployments, right? Most of the carriers here now, well, all of carriers are actually offering 5G service. T-Mobile's a a standalone system, and so one of the risks, arguably, is that the device market is just kind of still catching up. Um, while there are scores of new devices coming into the ecosystem every year, I think that's one of the downsides. It's you have to make sure you have a 5G compliant device,
Mm.
and if you have a 5G compliant device, it may cost a little bit more because the modems are still relatively expensive. So that's one of the downsides from a financial perspective, arguably. The other, I think, as we've kind of touched about, it's just the ignorance.
Mm.
And then maybe not knowing how it fits in. So there's that potential risk. So if an enterprise tries to go it alone, installs their own 5G system, they may not have the intrinsic capability or skill set to do that. So they may potentially introduce some risk from a security perspective in terms of gaps. But that's why you have to kind of augment, supplement, complement your strategy with a capable partner.
I mean, that's true of pretty much any technology, really, isn't it? Like, you can have a go at installing it yourself, and it might go perfectly well. But
Yeah.
Our advice to companies is usually like, stick to what you're good at. If you are manufacturing bottles, jet planes, books, whatever, stick to that. Like, let a capable partner take on the technology, because that's what we do. That's like our bread and butter, right?
Yeah, I think to your point, Martin, a lot of enterprises now have kind of made the transition to cloud. Most of them, at least, have some aspect of their environment running in the cloud, and that was a cultural shift, right? So you have suddenly IT giving up the keys of their kingdom to some third party that's managing their devices for them. And I think they realize now that this is fantastic. They don't have to watch blinking lights. They don't get those calls on the weekends. They don't have to worry about uptime or downtime. That's all someone else's problem. Yes, they pay for it as a service, but they pay for it as a service, which is really nice. It's not a huge outpouring of cash. The same is true for the models that we use at NetMaven with T-Mobile. So if T-Mobile comes in and they help an enterprise build a 5G network that's custom designed for their very needs, they're consuming that as an OpEx model, as a service. So that's really nice. They don't have to pump out loads of cash to get that expertise. They can immediately receive the benefit. The same is true with our partner Betacom that offers the CBRS as a service. That's a managed service. So again, I think culturally people have started to wrap their head around with services. Maybe security, network are kind of a little bit behind cloud in terms of the goodness feel, but slowly but surely, I think new people coming into the workforce, they're just used to it. So it will probably be a moot issue.
Sure.
Yeah, definitely. We've touched quite a few bases. We've got quite a few really good use cases there and looked at a few different industries. I wonder, Karl, if you could give us a few examples of where this has worked successfully and been adopted.
Yeah, sure. So I kind of touched on healthcare a wee bit. I'll just kind of give you guys a real world example. Last year, I was involved with a project with a partner of ours here in Massachusetts. There's a very famous hospital in Boston called Boston Children's Hospital. And Boston Children's Hospital is 3 million square feet in terms of their building right in the city. And they had huge issues with collaboration and communication between the clinicians and the staff. And the hospital was also going through a major digital transformation project where they were installing Epic. For those listeners who don't know, Epic is sort of like a centralized electronic health record system with a bunch of add-ins and plugins and applications that basically run the business of healthcare in the hospital. And what the partner that we worked with, when they did an assessment for the hospital prior to the Epic install, they realized that about 80% of the network of the application traffic would be mobile. So the hospital has this horrible Wi-Fi system. They're now facing this huge wave of transformation where even more applications would be over that Wi-Fi. So they were basically faced with a massive challenge. How are they going to fix this? So we proposed to them that they look and evaluate T-Mobile's 5G system. And T-Mobile's system, unlike the other carriers in the US, is standalone. So that means it's built from the ground up with the new 5G standard, which means it has a distributed core, which means that the core runs essentially in T-Mobile's cloud and the radios are on-prem. And they could essentially carve out a slice of that network for the hospital's own use, called an APN. And what that meant was the hospital now could solve for their collaboration, communication, mobility challenges, because the whole 3 million square feet is blanketed in this amazing 5G that's ultra reliable, highly secure, loads and loads of bandwidth, and the ability to add a lot of new use cases. Hospitals are going through massive transformation and digitalization. If you go into a hospital room today, there's about 20 different connected things in that one room. Beds, pumps, tools, all kinds of stuff. So having that kind of network capability, it has been a game changer and a real eye opener in the healthcare system. And we're starting to see now the healthcare systems wake up and realize, this is existential. We need to modernize our network in order to facilitate not only in-building communication and collaboration for clinicians, but more importantly, the big trend now is remote patient care. How do you support patients in their homes, and helping kids not have to go into the hospital who are sick in the first place to get that kind of care at home, which is really important. Another big use case for us is retail, believe it or not. So retail, obviously, since the pandemic has sort of shifted massively online, and brick and mortar stores are kind of struggling. And therefore, they're trying to get innovative and use technologies to kind of entice shoppers into their stores. So here, right, you can start kind of omni-channel, they call it, where you start at home, you start your shopping journey at home, then you get to the store. Perhaps the goods are ready for you because you've already communicated to the store that you're coming. And then to Martin's point, much like in industry, the stores now are using data, lots of data, to personalize the offer for you. I don't know if you remember that movie Minority Report, where the guy walks in, Tom Cruise, and it's like, hey, how's those jeans working for you? How about a t-shirt to go with that, right? So that's the reality we're nearly facing, because there's so much data that we give up about ourselves. And now with cameras that can, detect who you are, and basically customize offers for you. Now, I'm not there yet, but we had a big retailer here in the US that had 2,000 stores nationwide, and they had 170 ISPs, internet service providers, dealing. And imagine dealing with that. What a nightmare, right? So, but they actually had a third party manage the whole connectivity interaction, like all those dealers for them. And so with T-Mobile 5G, we were able to replace all of those internet providers and provide primary and secondary connectivity into the store. So that's a huge wave that's happening. And that's fixed wireless access. So essentially getting a 5G signal into the store that's then converted to Wi-Fi. And that eliminates the need for running cables in the ground. I know in the UK, the Port of Tyne, for example, is a collaboration and communications hub. And the port was facing increased load and increased digitalization, and they wanted to automate containers coming in and cranes and all that kind of stuff. And so when they looked and evaluated what it would cost to actually dig up, harbor full of concrete, it's needless to say very expensive, very time consuming, and just fraught with challenges. And so now they're able to employ, which they have, a private 5G system that is now able to scan devices on containers, automate that processing. It's much more efficient. It's much more time efficient, and saves a lot of money. So I think logistics, retail, manufacturing, and healthcare are some of the use cases that we're really seeing adopt 5G at scale.
Yeah, there's some really great examples, and God, would I love to walk into a shop and a voice said, Callum Minton, this is the polo shirt that you should be wearing this season.
Yeah.
But yeah, I mean, particularly in the retail and healthcare, as you sort of, it becomes more pertinent as they move away from the traditional bricks and mortar stores, and maybe we should do another podcast on healthcare, because that's a whole other
It's massive. It's really exciting. And not to interrupt you, but 2 weeks ago, I was at a conference called HIMSS here, which is one of the largest healthcare conferences in the States. And the week before that, there was another conference called Chime, very similar. But guys, the amount of digitalization, the amount of apps, the amount of amazing thinking that's happening. And we need it, right? Because the population's aging. After COVID, nurses and doctors are completely burnt out. It's a huge issue. So people are actually leaving the healthcare industry while the population is aging. So much stressors on the system, just like we talked about with baby boomers retiring. Healthcare needs to embrace digitalization at scale. And, you know, as we talked about, 5G is a great transport protocol to kind of unify all of that.
Just going back to your hospital example,
Mm.
installing this 5G network, you listed off a few of the different devices that might be connecting to this, because pretty much everything in a hospital now is data driven, it's connected somehow.
Yeah.
Are there challenges involved in, like, do you have to like retrofit some of these things, or do you just sort of cycle them out on a normal upgrade cycle? So if you've got
That's
like
yeah.
say there's such thing as a Wi-Fi enabled bed, do you have to
Yeah.
retrofit that with a 5G router or something, a modem?
Yeah, so that's a great question, Martin. Actually, you're right. There, arguably, the hospital would have to evaluate its device portfolio and ecosystem, and then figure out a cycle out, as you said, so at such point when 5G devices become ubiquitous. That's happening, but it's not here yet. There are some devices that intrinsically have a SIM. And with the advent of eSIMs, it's made it even easier, right? So now you can have a software SIM on the device. But to your point, there's still a lot of Wi-Fi connected devices and Bluetooth connected devices. So again, you get into this heterogeneous mix, and it really behooves a partner to be able to assess what's right for which use cases and how to kind of support the existing Wi-Fi infrastructure. So to answer your question succinctly, when you have a 5G connectivity coming in, any cellular device obviously can take advantage of that. But you can similarly route that through a 5G gateway, which will convert signal then into Wi-Fi. So you can kind of support both from the same sort of source, but you still have, you know, the device issue. Many devices now, though, the net new devices that are coming out are supporting 5G. So I think over time, we'll see more 5G devices just that are 5G intrinsically. But right now, we're in this kind of, I won't say weird, but interesting time.
Transitional phase.
The transitional phase, right? Yeah.
I think, like it's a core thing, and what we often say to our clients, I'm sure you do as well. We're not replacing, it's just as well as, it's another string to your bow, it's another tool on your belt, right? It's not, you're not coming in and going, right, throw everything in the trash, we're getting everything new, like it's going to cost billions. We're just enabling you to move in a different direction and have more conduits that you can explore. I mean, obviously with like 5G tech, if we're talking about like in a hospital, you've got staff that have got iPads or mobile devices and stuff, they're already ubiquitous in terms of having a 5G modem in anyway. It's just a sort of bigger ticket, like a Wi-Fi enabled bed or something that you'd have to look at on an upgrade cycle and when those bits of tech become available. But they were going to replace them anyway over time. So
yeah, and we're kind of going through that exactly at that particular hospital, right? So part of the 5G, the hybrid 5G deployment for the hospital was to solve the challenge of communication and collaboration for the clinicians. And so the hospital has about 18,000 staffers. The first block of devices that was part of the initial 5G contract was 4,000 iOS devices, so iPads and iPhones, to your point, 5G enabled. So now the doctors and clinicians have these smart devices that can essentially eliminate a bunch of different devices that they were carrying. So that eliminates that aspect. So there's a savings there. And over time then, as you mentioned, any new devices that come into the environment will be critically looked at as to say whether or not they support 5G. And then if they do, fantastic. But if not, you know, there are devices with dongles that could be added, for example, that can bring them into the 5G domain. Or similarly, with the case in Boston Children's, the existing Wi-Fi, as I mentioned, was completely offloaded, right? So all the mission critical applications and the core services from the Epic were running on 5G, and now Wi-Fi is being freed up. So essentially the devices that are still legacy, we'll call them legacy, that don't have 5G capability are now on a much better performing Wi-Fi network. So it's kind of a win-win.
Absolutely.
Now, as we're coming to sort of end of our allotted time, and by the way, we are going to touch base with you again, Karl. We want to talk about all the other industries that 5G can help, and not only 5G, just everything else. It's been really, really great catching up with you. As you know, the podcast is called Tech Will Save Us, so I'm curious from both of you. I'm curious as to your take as to which piece of tech you think will save us. Over to you, Martin, first.
I was really hoping you'd ask me second.
I can see you doing these ones.
I think probably outside what we've been talking about, but sort of advances in battery tech. We are moving more and more towards the world of renewables. We have to move away from fossil fuels. There are more useful things to be making out of oil, for one thing, than burning it. But to do that, we need to have better battery tech, and I think that is something that is going to sort of save us in terms of we'll be able to just take energy from the world in terms of wind, solar, hydro, whatever. The challenge with all those renewable sources is storage and getting it to where you actually need it. So yeah, I think future battery tech, anything that allows us to store more power in a smaller space for longer, and then use that where we actually need it to. That's what I think.
Yes, I'll go along kind of the same lines as Martin. I think maybe 5G enabled agriculture, believe it or not, right? So with climate change and water shortage is going to become a big issue. So with the ability to monitor soil and environmental conditions and then do precision farming, I think may ultimately keep the food chain alive. I think to automated farm vehicles where large farms can be controlled from a central location, like we kind of talked about autonomously, is going to be very important, because it seems like it's very hard to get people to get into the agricultural, or young people into that lifestyle, because it's so demanding, right? It's 7 days a week, it's 365 days a year, it's no break, it's a complete commitment, which, needless to say, as a consumer, we don't even think about that. We go to the shop and there's salad available in December. Where does that all come from, right? So precision farming, maybe industrial farming, the ability to use technology to create nutritional products for a world that's getting drier, I think will definitely save us.
Yeah.
Very good. Some really nice considered answers there. When all was going through my head was robots, so I can sit in my pants on my settee for longer.
That was my first
Yeah, see that. Listen, guys, it's been absolutely fantastic chatting to you today. Yeah, a very, very, very interesting conversation. I'm sure we'll have another one, Karl, on logistics, on operations, on healthcare, and all of the above. But yeah, just wanted to thank you for now, and for everyone else watching, and we'll catch you on the next one. Cheers.
Cheers, Karl.